Okay, so the last section in chapter 2 is all about rate of change and tangent lines. We've talked about this earlier in this chapter. The most common rate of change is speed. Anytime a rate is when you're measuring two units against each other. Miles per hour, cost per gallon, dollars per hour, any of that. But you're always putting it when we're talking about time. A lot of times you're going to see the amount of change over the length of the interval. All right, so for example, on this interval, using this equation to find the average rate of change, anytime the word average is involved, you just want to find 2 points. One, these are the x intervals. F of 1 is 0. F of 3 is 24. Then the average rate of change is really just your slope. All right, so we just take the y value minus the y value over your x minus your x, which is 12. So key average is slope. Okay, so if we look at this curve, we can find the slope of 2 points just by estimating your y values and finding the slopes. Oh, that was bad. Finding slopes like this. And your average rate of change, notice this is time in days, number of flies. So it's flies per day. The rate will always measure the y label over the x. Slope of a secant. Secant is 2 points. Slope of a secant is your average rate of change. Okay, now this is going to start getting into your calc stuff. If it does not say average, you're always going to be looking for instantaneous. Oh, you know what? I didn't actually put the example. What was the example? Sorry. We're looking at the slope of this point and this point. So y minus the y over x minus the x. And this is approximately 8.6 flies per day. Sorry, I didn't type that in there for some reason. Okay, example 3 though is kind of the crux of this situation. All right, so we're going to call this point, say 1, 1. This point, because this is x squared, 2, 4. So we have points all the way along here making up this curve. Now, if it just says at 2, if there's not an interval, this is your instantaneous speed. Even though it doesn't say speed, your average slope versus your instantaneous slope. So our interval, that's where we get the 2. And we say 2 plus h just a little bit after 2. So we're going to use the point 2, 4. Remember, we're using x squared and 2 plus h. And then this is going to be f of 2 plus h is 2 plus h squared, just plugging each of these into x squared. So when we square the quantity, that's 4 plus 4h plus h squared. So our slope at 2 will be our y minus our y over x minus x. This should start looking a little familiar. If you do this correctly, you're going to cancel out everything that does not have an h. Now, this is where you want to factor out h from the front. And then the h's cancel. And we're left with 4 plus h. Now, in order to make this exactly 2, h has to be 0, and it would be at exactly 2. When h equals 0, our slope is 4. So what that's saying is there's a tangent line at 2, and the slope of that tangent, think of it as, that line butting up against the curve at that 1.2. The slope of this line is 4. Now we have a point and a slope. So I can write my tangent line, y minus the y coordinate equals the slope times x minus the x coordinate. Done. That's all you want. This slope, the equation of the tangent line is the line you're going to be writing all year long. So here's an actual definition. The slope of a curve at a point is just at this coordinate point, the slope is the limit as h approaches 0 of f of a plus h minus f of a all over h. And that's technically what we've been doing. All right, so go ahead and get that copied down, and we're going to use it on the next example. Okay, so if f of x is 1 over x, we need two things from this previous definition. F of a plus h, f of a. F of a plus h is 1 over a plus h. F of a is 1 over a. Now, you're going to get annoyed, but every single time you do this, you're going to write the limit as h approaches 0 every single time. F of a plus h is 1 over a plus h minus f of a all over h. Okay. Now we need to get a common denominator. So I'm going to multiply top and bottom of this by a plus h because it's missing the a plus h. I'm going to multiply this top and bottom by a. I have to carry down the limit as h approaches 0 of a over, I'm just going to leave this in factored form, minus so I just got a common denominator here, put it all over the common denominator, each one. So I'm going to carry over the limit as h approaches 0 of a minus the quantity a plus h. Let's put it all over the same denominator. Now, when we distribute that negative, the a's cancel, and I'm left with the limit as h approaches 0 of negative h over a times a plus h all over h over 1. We now have a complex fraction. When I divide by h over 1, it's the same thing as multiplying by 1 over h multiplied by the reciprocal. This h factor on the top cancels this h factor. The limit as h approaches 0, we're left with negative 1 on the top over a plus h. Now, once I cancel these h's, I can now plug 0 in for h, and I get negative 1 over a squared. Okay. Now, letter B says, where does the slope equal negative 1/4? This was the hardest part. This was getting letter A. Everything else is not too bad. So, if this is our slope, when does this equal negative 1/4? Well, we just solved this for A. We solved this equation for A. And I'm just going to multiply. We get negative 4 equals negative a squared. Positive 4 equals a squared. A equals plus or minus 2. Now, let's think about y. If I graph 1 over x, like this, this is saying there is a slope of a tangent line at plus or minus 2. See how good I did. That's probably not the best, but this one probably is better. See, if you did this right, these both would be parallel, and they both have a slope of negative 1/4. But my graphs are bad, so I'll show you better when we get into class. I'll put up a graph, and we'll go from the actual grid paper. So you could notice on this, everything is always negative. And if you look, if the equation is negative 1 over a squared, this will always be a negative number. And the bigger the number gets, the more shallower the slope gets. All right. So where tangent is just your slope of the original curve, the normal is the perpendicular to the tangent. So you're going to do everything the same. Think of the chapter 1 test where you had to do the parallel line and the perpendicular. That's all this is. So you find the slope using the limit as h approaches 0 of f of a plus h minus f of a all over h. Now we're going to use this function. All right, so we need f of a plus h, which is 4 minus a plus h squared. And I'm going to go ahead and simplify. So this would be a squared plus 2ah plus h squared. Then we're going to distribute. And then we need f of a, which is 4 minus a squared. All right. Now I'm going to substitute this in for f of a plus h, this in for f of a. Be extremely careful. This minus means I'm subtracting all of f of a. So the limit as h approaches 0, I'm going to move this a little. All right, so notice this is my f of a, and this is my f of a plus h. Now we just simplify. When I distribute this negative, the a squared cancels the a squared, the negative 4 cancels the positive 4. Everything without an a cancels. H. Then we can factor out an h, cancel the h, plug 0 in for h, negative 2a. Okay, and find the slope when x is 1. Notice I'm just going to keep this limit all the way through. As soon as I want to find a slope at a point, I'm going to change this to m. If a is 1, negative 2 times 1 is negative 2. Now we need the slope, or the point. When x is 1, what's the y value? 4 minus 1 squared is 3. All right, so our tangent is y minus the y coordinate equals the slope times x minus the x. Now, if this is my tangent, what's my perpendicular? Positive, the opposite, reciprocal, 1/2. So now my normal is y minus the y equals the perpendicular slope times x minus the x. Notice the only thing that changes at the tangent and normal is the slope, because I'm looking for it at that point. So think of the curve. Four minus x squared at 1, 3. This is my tangent line, negative 2. This is my perpendicular normal line, both of them at the point 1, 3. All right, so this is technically just more of the same. My bell's gonna ring here. We'll finish up this one in person, and usually this is kind of what we have time for during class. So I'm gonna quit the notes here and we'll continue later.